This is Mr. Martin. In this video we are continuing with special right triangles. In the last lesson we looked at 30, 60, 90 triangles, and we figured out that each of the sides is always going to be in the same ratio, which helps us to figure out missing parts of a 30, 60, 90 triangle. And in this video we're going to look at another special right triangle called 45, 45, 90 triangles. So below are three squares. Given each side length, determine the diagonal length in simplified radical form, of course. Determine all angle measures in each triangle. So we're given that these are squares. So we know that all the angles are going to be right angles. There we go. Right angle, right angle. And then we have one diagonal drawn in each. And this diagonal, if you remember, is going to bisect the opposite angles. So I know that these are going to be congruent. And these are also going to be congruent. And all these halves of the right angles are also going to be congruent. So these are all going to be 45 degrees. Alright, and then for this first square, that we know that A is equal to 1, so we have 1, 1, 1, 1, and if we want to find the diagonal, we can use the Pythagorean theorem. So 1 squared plus 1 squared is equal to D squared. So D squared, 1 is squared is 1, another 1 squared is 1, so that's 2. So then I take the square root of both sides, and I get D is equal to the square root of 2. Alright, let's move on to the other side again. All the angles of the square are right angles, and then these angles in the corners are going to be 45 degrees. And now we're given that A is equal to 5, so each side of the square is 5. And we'll use Pythagorean theorem to figure out what D is. So we have 5 squared plus 5 squared is equal to D squared. So 25 plus 25 is equal to D squared. So D squared is equal to 50. D is equal to the square root of 50. We'll do a tree for this. So 50 is 2 and 25. And then 25 is 5 and 5. So here's a pair of 5s. So this is going to be 5 root 2. So if we look at the first example, we could put a 1 here, and this would be 1 root 2. So length of the side root 2 for the diagonal. And then for this one, it's 5 root 2. So length of the side times root 2. So as mathematicians, we like to look at patterns, and if we were to guess for this one, D over here is going to end up being 10 root 2. So we could go ahead through this process again with a side length of 10, and then do a tree for our value of D, and we're going to end up with 10 root 2. So what we see here, so let's finish filling out this table before we look at the patterns for the sides there. So the angle measures. For this one, it doesn't make as much sense, but you know, for the half, we'll look at the angle measures for these triangles that are half of the square. So the angle measures are going to be 45, 45, 90. Again, that's going to be our second special right triangle, 45, 45, 90 for all three of these. And then the leg measures here were 1 and 1, and here the leg measures were 5 and 5, and here they were 10 and 10, because this half of the square here, this is a right isosceles triangle. It's right because it has a right angle in the corner here at D, and it's isosceles because the two legs A, the two A's, are the same. And then the hypotenuse measure for the triangle with side length 1 was root 2. For the triangle with legs 5, it was 5 root 2. And for the third one, it was 10 root 2. So it's a little more straightforward of a pattern than with 30, 60, 90s. So what do you notice? The sides of a 45, 45, 90 triangle are always in the ratio of 1 to 1 to root 2. Okay, so if you remember for 30, 60, 90s, it was 1 to root 3 to 2. 45, 45, 90s are a little bit more straightforward because the two legs are the same. Okay, so we can skip this table here. That'll be the end of this video. Make sure if you ask questions, if you have any questions, you make sure you get them answered, and we will see you in the next video.